This tutorial will help you to learn how to write zero and negative exponents in an equivalent manner. Let's take a look here and see if we can understand what happens when anything is raised to a power of 1. So 5 to the power of 1 is 5, 8 to the power of 1 is 8, 2/3 to the power of 1 is 2/3, and r to the power of 1 is r. So due to the fact that raising anything to the power of 1 does nothing or leaves the item remaining the same, we generally do not write anything to the power of 1. We simply write an item as itself. So raising anything to the power of 1 means that 1 can be an invisible power. So if ever you see the letter R, it has a power of 1 next to it. If ever you see the number 8, it has an invisible power of 1 next to it. All right, let's move to a different power. What do you think the rule is if a number or item is raised to the power of 0? 5 to the power of 0 is 1. 8 to the power of 0 is 1. 2/3 to the power of 0 is 1. And r to the 0 power is 1. Any item raised to the power of 0 will result in the number 1. All right, let's go to our third rule. Negative powers. Take a minute to pause the video and think about how you might state this rule. Anything raised to a negative power is blank. Pause the video and think about it now. All right, hopefully you took some time to observe what happened when an item was raised to the negative power. It doesn't matter if your power is -2, -3, or -4, or -17, it doesn't matter. The power number doesn't matter. But the fact that the number is negative does something to a value. So I started as the number 5, but I ended as the number 1/5. I started as the number 8, but I ended as the value 1/8. I started as a 2/3, but I ended as a 3/2. I started as an r, but I ended as a 1/r. Do you see what the rule is here? Hopefully you're noticing that anything raised to a negative power has to be flipped over. We call that a reciprocal. So if an item has a negative power, you take its reciprocal. And if a number isn't a fraction, which is typically what you think of when you think of a reciprocal, you simply put an invisible 1 underneath. That's why all of these items have 1s in them, because technically there were invisible 1s in their denominators. This one already had its own numerator and denominator, so we did not need to introduce the number 1. We simply swapped the position of the 2 and the 3, giving us a 3/2. You'll notice, after we take the reciprocal, what happens to the power? After we take the reciprocal, what happens to the power? It becomes positive. So that's the rule that we're going to be working with. Anything raised to a negative power will become positive if you take the reciprocal of the base. The base is the number or letter or fraction here, right? That the power is being used on. Okay, let's summarize and then we're going to review. Anything raised to the 0 power, except the number 0, will be defined as 1. 1 to the 0 power is 1, 2 to the 0 power is 1, 3 to the 0 power is 1, 4 to the 0 power is 1, x to the 0 power is 1, w to the 0 power is 1, 5/7 to the 0 power is 1. Any number, unless the number is 0. Let's review the negative exponent rule, and that is any item that is being raised to a negative power can be made positive. That's what this plus n means right here. That positive n means that the power will become positive once you take the reciprocal of the item. All right, get your scrap paper handy. Let's try a few examples here. Remember, your learning target is that you can write equivalent expressions for 0 exponents or negative exponents. Hopefully you jotted down these rules or you remember them. You can always pause the video or rewind it if you need to come back to the screen. Here are your first 4 examples. Pause the video and try to write them by simplifying using the rule you learned. Okay, hopefully you pause the video and you realize that every single one of these is equal to 1. All right, let's try our negative power rule. Please pause the video now. All right, you'll notice the directions here say rewrite using positive exponents. So they don't want you to perform the operation of the exponent. They simply want you to write it in an equivalent manner. Meaning, take the reciprocal of this base and then make the power positive. Number 2, take the reciprocal of this base and then make the power positive. Number 3, take the reciprocal of the base, make the power positive. Number 4, take the reciprocal of the base and make the power positive. That's it. Oops, I forgot. Parentheses. That's important. We're squaring the whole fraction, not just the 5. All right, I'm going to show you one more thing. This direction on this screen actually says to simplify, whereas the direction on this screen said rewrite using positive exponents. So even though a negative exponent cannot be computed, once you make that exponent positive, you actually can do the math sometimes. In this case, it would be 1 over 4 squared, or 4 times 4. So if you're asked to use positive exponents, you need to leave your answer in exponent form. But if you're asked to simplify, then they actually want you to perform the math. Same is true here. 1 over negative 6 to the 3rd power would be how to write it with a positive exponent. 1 over negative 216 is what it would be if you'd performed negative 6 times 6 times 6. Now be careful. That negative 6 to the 3rd power there, this negative sign is not included. It is not included in the math. This is a negative sign, and then 6 is being raised to the 3rd power, not the whole expression. All right, let's take a look at number 3. Once we make that power positive, can we simplify it any further? No. We don't know what W is, so that is our final answer. For number 4, this fraction 2/5, when we make this power positive, will become 5 over 2, and then the power is positive. When you raise a fraction to a power, you put that power to the numerator and to the denominator. So we'll get 5 squared and 4 squared. All right, hopefully you've had an opportunity to try practicing these new rules. Here's your exit ticket. If you can get this right by reading the directions carefully, then you have successfully reached your learning target. Let's take a look at your answer. Now, because I said write using positive exponents, you cannot give me this answer. That would be the answer if I said simplify, not the answer if I say write using positive exponents. All right, that concludes our tutorial.